Hi, this is Wendy Lightheart, and in this video we're going to learn how to solve rational equations. So first let's look at the steps of how to solve a rational equation. The first step is that you want to determine what values of x will make any of the rational expressions in the equation undefined. Because, of course, any value of x that would make any of the expressions undefined couldn't possibly be a solution to the equation. So if we end up with any of those values as a proposed solution, we'll need to throw that solution out because it cannot truly be a solution. Our next step is to find the least common denominator of all the rational expressions in the equation. So it doesn't matter how many of them there are. You want to look at all the rational expressions on the left side and the right side of the equal sign and find the least common denominator of all of them. Then what you're going to do is multiply both sides of the equation by the least common denominator. So remember that it's okay to multiply both sides of the equation by the same thing, and that's what we're going to do. And when we multiply both sides by the least common denominator of all the fractions involved, this will actually clear the equation of all the fractions. Then you're going to end up with a new equation, and this new equation may be linear or it might be quadratic, and whichever form it's in, you'll need to use the proper methods for solving that new equation, and that will give you your proposed solutions. Then you're going to want to check the proposed solutions in the original equation. It's always a good idea to check your answers, but also you want to make sure that those proposed solutions do not include any of the values that you listed in step 1, because remember, they can't possibly be solutions since they would make one or more of the rational expressions in the equation undefined. Okay, let's look at an example. Here we want to solve this rational equation 4 over x equals 2 minus 2 over x minus 2. So first we need to think about what values of x would make any of these rational expressions undefined. So if we look at 4 over x, that's one of the rational expressions, what value of x would make that expression undefined? Well, that one's pretty easy. If x is 0, we'd have 0 in the denominator, and that would make the expression undefined. So 0 is going to be one of those values. And then the other rational expression, 2 over x minus 2, notice that if x is 2, that would make that denominator 0, which makes that expression undefined. So the values that we're going to want to throw out, if we happen to get them as proposed solutions, would be 0 or positive 2. So we just want to keep that in mind. Okay, so now we're going to work on solving this equation. And to do that, the first thing we want to do, or the next thing we want to do, is find the least common denominator of all the rational expressions. So notice that the two rational expressions we have here, the denominators are factored as much as possible, and they don't have any common factors. So we're simply just going to multiply those two denominators together, x times x minus 2, and that's going to be our least common denominator. Remember, what we do with that least common denominator is we're going to multiply both sides of the equation by the least common denominator. So here we have the 4 over x will get multiplied by x times x minus 2, and the 2 minus 2 over x minus 2 will also get multiplied by x times x minus 2. Notice on the right side of the equal sign we actually had two terms, so we're going to have to distribute that LCD through those two terms. So we're going to have to multiply the 2 times the x times x minus 2 as well as the 2 over x minus 2 times the x times x minus 2. So when we do the multiplication, right now this is just showing that distribution step. So notice that the 2 is getting multiplied times the x times x minus 2 as well as the 2 over x minus 2 expression. And now we should see all the fractions get cleared as we cross the common factors out. So notice that these x's will cross cancel in the first expression. So that denominator completely canceled out, so that fraction is going to be gone. And then if we look at the far right side, the x minus 2 factors will cross cancel. So now all the denominators are canceled out, and which is the whole reason why we multiplied both sides by the least common denominator. And so if we simplify, on the left side we would distribute the 4 through the x minus 2, so that would give you 4x minus 8. And then the x times x minus 2 times 2, if you combine the 2 and the x together and then distribute those through the x minus 2, that will give you 2x squared minus 4x. And then on the last expression here, the x minus 2 is canceled, so we only have x times 2 left, and x times 2 we would write as 2x. Okay, so here's our new equation without any fractions, and we're going to want to solve this new equation. So on to the next slide. Now what kind of equation is this? This is a quadratic equation because of that x squared term, right? So we're going to need to solve this by factoring, since that's really the only method we've learned so far for solving a quadratic equation. And to do that, we're going to have to get 0 on one side. So we're going to have to combine the 4x and the 2x terms on the right, and then subtract 4x from both sides. And then we also want to add 8 to both sides to move those two terms to the right side. So once you do that and simplify, you should get 0 equals 2x squared minus 10x plus 8. Now we're ready to factor, and the very first step of factoring, of course, is to look for greatest common factor, and we do have a common factor of 2, so we'll go ahead and factor that out. And now we have a trinomial with no leading coefficient besides a 1. So we can go right to two sets of parentheses, and we're looking for two numbers of multiply to give us 4 and add to give us negative 5. And those numbers, of course, would be negative 1 and negative 4. So now this is factored completely, and remember that once you factor everything and you have it set equal to 0, then you can use the zero product principle and set each of those factors equal to 0. So whatever makes the factor x minus 1 equal to 0 will be a solution, and whatever makes the factor x minus 4 equal to 0 will be a solution. And of course that GCF of 2, since that's a constant, that's not going to produce any solutions because there's no way to make that factor equal to 0. So we end up with two solutions, x equals 1 and x equals 4. Notice that neither of those numbers were the values that we found in step 1, because remember the values we found in step 1 was 0 and 2, so we don't have to worry about throwing out any of these solutions. And of course you should go ahead and check by going back to the original expression and plugging in 1 and seeing if you get a true statement, and then doing the same thing for x equals 4. Alright, so have fun checking your answer, and we will see you later. Thanks, bye-bye.